This is part 8 of the series Parallel and Perpendicular Lines, and in the last part we introduced the concept of slope, and we did that to begin our discussion of the issue of parallelism and perpendicularity in the coordinate plane. And so to begin this video, what we're going to do is we're going to start by calculating the slopes of various lines in a coordinate plane. So here we have line O, line L, line M, and line N. We're going to go ahead and calculate the slopes of each one of these lines using the slope idea that we looked at in the end of the last video. So let's jump in here and let's take a look at the slope of line O. Now, one way to think of slope is you can think of it as you're driving along a road from left to right and you come to the top of a hill. When you go in this direction, you're going downhill, so that's a negative slope. Likewise, if you're going this way, you're going to this point, you're going uphill. So this is a positive slope. So this is a negative slope, this is a positive slope. We'll look at lines L and N in a little bit. But first, let's take a look at this negative sloped line. What we're dealing with in slope is we're dealing with a measure of the slant of this line. It's a ratio of the change in the y direction divided by the change in the x direction. So just to recap from what we talked about last time, we said that slope is the rise over the run. That's in layman's terms, which is the change in the y divided by the change in the x direction, which is the difference of the y's, so y2 minus y1 divided by x2 minus x1. And that's what we're going to use to calculate slope. So here, that's all we have to do to find the slope of line O is pick 2 points on the line and find the difference of the y coordinates divided by the difference of the x coordinates. Now mathematically, it doesn't really matter which point you use. If we take these 2 points, it doesn't matter if we use these coordinates, subtracting these coordinates from them, or if we subtract these from these. It's not going to matter one way or another. So just pick the one that's convenient to you. Convention usually indicates you use the one on the right minus the one on the left, but it really doesn't matter. So to find the slope of line O, that's going to be the change in the y's, which is going to be 10 minus 4, divided by the change in the x's, negative 3 minus 5. Now notice we started with a 10 and went to 4, so we have to go back to this point to use the negative 3 minus the 5. We couldn't start with the 10, subtract the 4, and then go to the 5 and subtract the negative 3. That would mess everything up, and you have to be consistent. If you start with this y, you have to come back to that x. So it's negative 3 minus 5. That gives us 10 minus 4 is 6, divided by negative 3 minus 5 is negative 8. That simplifies. This divides by 2 to 3 over this divided by 2 is 4, and it's a negative 3/4 slope. So what that tells us is the slope of this line, we would move downward 3 units and to the right 4 units. So we move down 3, 1, 2, 3, and to the right 4, 1, 2, 3, 4. Down 3, 1, 2, 3, to the right 4, 1, 2, 3, 4. And that works out fine. Now let's go ahead and find the slope of M. So the slope of line M is going to be the difference in the x's and the difference of the y. So we do the difference of the y's first. So negative 2 minus 10, negative 2 minus 10, divided by the difference of the x's. 1 minus 9. 1 minus 9. So negative 2 minus 10 is negative 12, and 1 minus 9 is negative 8. Well, a negative divided by a negative is a positive number. And then if we simplify this, this divides by 4 3 times, so this is 3. And this divides by 4 2 times. So this is a slope of 3/2, which means we go up 3 units because the sign is usually associated with the y direction. So this we went down 3 units because it's -3. Here we're going up 3 units because it's +3. So up 3 and to the right 2. So up 3, 1, 2, 3, to the right 2, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. So that's the easy way to calculate slope. So that gives us the negative slope line and the positive slope line. Now what happens when we get to this horizontal line here, line N? Let's calculate that out. So the slope of line N is the difference of the y's. So it's 4 minus 4 divided by -3 minus 14. -3 minus 14. Well, 4 minus 4 is 0, divided by -3 minus 14 is -17. Well, 0 divided by anything is just 0. So this line has a slope of 0. Now you don't say that this has no slope. It has a slope of 0. And any line that has a slope of 0 is a horizontal line. And we're going to talk about the equations of horizontal and vertical lines in a bit. But right now, we're just interested in the slope of the line. So this line has a slope of 0, so therefore it's a horizontal line. Now let's take a look at the slope of this vertical line, line L. So the slope of line L is, let's take this one minus this. So we have 11 minus a -3 divided by 5 minus 5. Well, 11 minus -3 is 11 plus 3, which is 14. And 5 minus 5 is 0. Well, anything divided by 0 is undefined. This number goes to infinity. Now, a way to think of this, if you've ever wondered why you can't divide by 0, take a look at what happens when you have, let's just say we take the number 1/2. That's 0.5. And let's make this a little bit smaller on the bottom. 1 divided by 0.2. Well, 0.2 goes into 1 5 times. Let's make this a little bit smaller yet. 1 divided by 0.02. Well, that's going to go in to 1 50 times. 50 times 0.02 is 1. And let's do it one more time. 1 divided by 0.002 equals 500 times. Now, as you can see, as the denominator gets smaller and smaller, it goes into the numerator more and more times. So realistically then, as this number approaches 0, this number is going to approach infinity, because 0 goes into 1 an infinite number of times. You can take 0 away from 1 an infinite number of times and still have 1 left over. So that's why you can't divide by 0, because it's an undefined number. So the slope of line L, its value is a non-real number. That's why we use the symbol infinity, because there is no number that represents infinity. Any number that you come up with, you can always come up with one greater than that, and that's the idea of infinity. So we say that the slope is undefined. It is a misnomer to say this line has no slope. This line has an undefined slope. It's a vertical line. So clearly it has an orientation. This has a 0 slope. That is, it goes up 0 units for every unit it goes in the x direction. This goes up an infinite number of units for every unit it goes in the x direction. So that's why this is an undefined slope and this has a zero slope. So horizontal lines, zero slope, vertical lines, undefined slope. And that brings us to the idea of parallelism and perpendicularity in the coordinate plane. I think you can clearly see that a horizontal line and a vertical line has a particular orientation to each other, and this line and this line have a particular orientation. We're going to look at the orientations. What does it mean for two lines to be parallel and perpendicular with respect to slope in a coordinate plane? So that's the first thing we're going to look at next. Now, when you're discussing parallelism and perpendicularity in a coordinate plane, the key concept is slope. So let's take a look at the slopes of parallel lines. Here we have two lines that in the picture appear to be parallel. Now, we have said many times that never trust the picture. So we're not going to trust the picture. I want to determine if these two lines are parallel. Well, the way to determine that is in a coordinate plane, any two non-vertical lines are parallel if and only if their slopes are equal. And notice it says any two non-vertical lines. And the reason for that is because you can't compare the slopes of vertical lines because they're undefined. There's no number to compare to. So we have the caveat that's added to this idea that all vertical lines are parallel. So we know that if we have a vertical line like the y-axis here, any line that's vertical is going to be parallel to that line. So we're looking at non-vertical lines. Let's look at line AB and line CD. And let's go ahead and calculate the slope of that line. So the slope of AB is going to be the difference of the y's, 5 minus 9, divided by 5 minus 9. That's convenient. Which gives us negative 4 divided by negative 4, which is a positive 1. So the slope of this line is 1. Now let's look at the slope of CD. And we have the difference of the y's, 4 minus 8, divided by 7 minus 11. So 4 minus 8 is negative 4, and 7 minus 11, negative 4. So again, we have a positive 1. These two lines, AB and CD, have exactly the same slope. Therefore, by our definition of parallel lines in a coordinate plane, these two lines are parallel because they have identical slopes. So let's take a look then at line EF. Let's calculate the slope of line EF now. So we have the slope EF, which is 9 minus 3 divided by 5 minus 11. 9 minus 3 is 6, and 5 minus 11 is negative 6. So this gives us a negative 1 slope. Well, clearly this line is not parallel to either of these two lines because those lines have different slopes. But let's take a look at what they actually are. Here we have the definition of the slopes of perpendicular lines. In a coordinate plane, any two non-vertical lines are perpendicular if and only if the product of their slopes is equal to negative 1. So here you can see that the slope of AB is 1, slope of EF is negative 1. 1 times negative 1 is negative 1. So by this definition, AB is perpendicular to EF. AB is perpendicular to EF. Likewise, CD has a slope of 1. EF has a slope of negative 1, so CD is perpendicular to EF. We have this added caveat here that says vertical lines are perpendicular to horizontal lines. That covers the case when you have a vertical line. So slopes of parallel lines are equal. Slopes of the product of the slopes of perpendicular lines are negative 1. All vertical lines are parallel, and vertical lines are perpendicular to horizontal lines. That wraps up this part, and I'll talk to you in the next video.